Good morning. How are you guys? Welcome to Wednesday, short day, which is great. I hope you are doing well and these videos are helping you. We're gonna get right to it. Today we are on 4.3. So let me get my other computer going here. All right, and we'll share the screen. If you could get your pencil and your binder paper ready, as well as your red resource book and your notes. Your notes actually for this assignment are more beneficial. So let's take a look here, math chapter 4, and we are on 4.3. There it is. I need to get my Chromebook here all flipped around so I can write on the screen. Oh, there's my friend Becky. Let's see. Uh-oh. What did I do here? There we go. All right, 4.3. And looking at this number one, it's talking about a scale drawing. What is a scale and a scale factor? And if you were to look in your red resource book at 1A, it's actually not helpful. But in your notes number 30 for scale drawings. Oh, if I can pull this part here out. Here it is, scale drawings number 30. So I'm going to read this to you. A scale drawing, a proportional two-dimensional drawing of an object. Scale model is then going to be a 3D version of that. So the scale gives the ratio that compares measurement of the drawing or model to the actual measurements. Okay, so when we look at this for number one, it says that a room is 20 feet by 35 feet. Okay, so 20 feet by 35 feet. And here's our scale drawing. So looking at it, we have 2 inches by 3.5 inches. Okay, so this is a scale model. In looking at this, we have 2 inches. I want that fatter. Let's see here. 2 inches is the black fat ink better for you guys? I hope so. All right, 2 inches is going to represent 20 feet, where we have 3.5, so that's from this one. And then we have 3.5 inches. Oh, what am I doing? 3.5 inches is for 35 feet. Okay, so now we have to figure out what is it, what is 1 inch? Okay, so, and I don't know if my face is covering it there on mine. It should show. So ultimately, we want to know how much is 1 inch representing. So if we have, let's see here, we're going to say 1 inch. So let's just take this top one here. So if we have 2 inches for 20 feet, what does 1 inch represent? Well, we have a scale of 1 inch, 1 inch to 10 feet. All right, and we can look at this other one here and say, okay, if it's 3.5 to 35, then is 1 inch going to be to 10 feet? And yes, it will be. So that is our scale. That is the first part of our question, okay? 1 inch to 10 feet. So our scale factor, a scale factor is a scale without units when the units are the same. Okay, so now we need to take our scale and then make the units the same. So if we have a scale of 1 inch to 10 feet, then what is that if we convert the whole thing to inches? Okay, so we still have our 1 inch on top. And then down here, how many inches are in a foot? 12 inches. Good. So we're going to say 10 feet times 12 inches. And that's going to give us a scale of 1 to 120, or the way that we would write that is same that we did the scale, 1 to 20. And, I've actually been seeing this lately, it's coming to be Christmas. And of course I have 2 little boys. So I always look at remote control cars, right? And you'll see the scale on the side. So a lot of times you'll see it 1 to 24. So that'll look like just like this, but instead of the 20, it has that 24. So that's going to be a scale. So it is used in real life. And a lot of times you'll see it with house plans. So that is scale and scale factor. Okay, erase all of this. And next, it looks like Shannon, who knows if she's making a smoothie, a fruit salad? Not sure. All right. Let's see. And let's see if I can move it up and give myself some more writing room. There we go. All right. So Shannon, here we are, number 2. Shannon uses 1.5 cups of pears for every 1/8 cup of apples. How many cups of pears are needed if it's a he, Shannon, sorry, uses 1 cup of apples? Okay, so if at first Shannon has 1.5 per 1/8 cups of apples. So we have pears to apples. Then how many are needed? Ooh, I wrote way too big. Of pears for 1 cup of apples. Okay, so then we're going to cross multiply. And that's going to give us, I'm just going to continue it right here. So that's going to give us 1/8 n. Let's see if I write a little smaller. Got the fat tip on, but actually looks good. Like I'm writing with a Sharpie. I kind of like it. All right, 1/8 n equals 1.5 times 1, which of course is just 1. Okay, so now we have 1/8 n times 1 and 1/2. So I am going to make that into an improper fraction so that we can simplify. 1/8 n equals, we're going to go 2 times 1 is 2, plus 1 more is 3. Now, to get n by itself, we have 1/8 times n, and so we need to do the opposite, which is division. Well, we know that when we are dividing fractions, you actually multiply times the reciprocal. Okay, so we're going to flip the 1/8 over, and that's going to be times, I use parentheses, 8 over 1. Okay, and the reason we do that, look, it cancels out. 8 goes into 8, 1 goes into 1. Okay, so whatever we do to one side of the equal sign, we have to do to the other. We can simplify this. 2 goes into 2 once. 2 goes into 8 4 times. So now that leaves us with 3 times 4. So n equals 12. And let's look to see what we need. So that is going to be cups, pears. All right. So Shannon is making either a giant fruit salad or a smoothie. Who knows? But that's a lot of pears. Okay. Erase all of this. Going on to number 3. So number 3 has this fun thing, reference to Dorito. I have no idea what that means, but I do love Doritos. So I would like to find out what Dorito means. So hopefully it's something fun. I see the word Dorito and I assume it's fun, right? Super cheesy. Who knows? Maybe it's a little Cool Ranch. All right, number 3. All right, so we are going to solve n minus 2 equals -5. Okay, first thing that we need to do is add the opposite. So we have n minus 2. We're just going to make that n plus -2. And now that we've done that, to get n by itself, we're going to add the opposite. So add 2 to both sides. Leaves us with n equals -5 plus 2 is going to leave us with -3. Okay. Now it says, check your answer. Here's what you do. You simply plug in the value Ooh, all right, I'm writing in purple, but I'm using a fat tip, so hopefully you guys can see it. So I don't know if you guys were having the problem with the color or whatever. So I'm just gonna plug in -3 for n. So if I were to put -3 plus -2 equals -5, is that correct? Correctamundo, -5 does equal -5. So yes, this is the correct answer. All right. There is your classwork or part 1 for today. And then, oh, I meant to delete that before I saved it as a PDF. How can I, well, oh well, because look at, now I have it down there so I can do the problems, but I didn't delete that off of my slide. I wonder if I could, do I have a white? I do. All right, I wonder if this will work. All right, I'm totally just scribbling white over this one. You know where it's going to mess me up is when I try to erase my problem. Maybe I can do the work under it, but this way it's just not distracting. All righty. There. All right, now at least it's just not in our way. Okay. And back to black. And there we go. All right. So number 1 says that we are doing -3n plus 6 minus n minus 5. And we saw this the other day. And we need to distribute. And looking at both of those parentheses, the first section here, that is multiplied times a +1. However, the second one has that negative sign, which means that we're going to multiply it times -1. Okay, so following this example right here, and we are going to distribute, let's see, you know, I'm just going to work it out, and maybe we'll put the example over my scribble. Yeah, we could do that. All right, number, oh, okay, already messed up. It's all right. Number 1. Okay, number 1 has -3n plus 6 minus n minus 5. Okay, so to distribute and get those parentheses out of there. And the reason we're doing that is so then we can combine like terms. Okay, so our first set is times a +1, and the second one is times a -1. So it's easy peasy for the first one. 1 times -3n gives us -3n plus 6. And then we have a -1 times n gives us a -n. And you'll see that I'm just going to add each of these terms. So, but I'm going to add a -n plus, so I have -1 times -5. That's going to give me a +5. So now I'm going to combine like terms. So here's my 2 n's right here, and then 6 and 5. So -3n and another -n gives me -4n plus, then I have a +6 and a +5. It's going to give me 11. Okay, and we double check. Yep, we match over here. So let's see here. So we distribute the 1 and the -1. Did that. Step 3, combine like terms, same variable to the same power. Did that. And it says recall when multiplying or dividing with the same signs, it's positive, different signs is negative. So we have that. And then when we add, we have to ask, do we have more positive or more negative? How many? We got that. Okay, so that one was for number 1. And let me see how it is going to erase. It should go layer by layer. Oh, no, undo. Undo. There we go. All right, so we're just going to leave that one up there. And I think I can go one thicker. That would be helpful. And I'll just do the work down at the bottom. All right, so up here is number 1. And here we have number 2 down here. Oh, I don't know what I was writing there. All right, number 2. Okay, so for number 2, we have 4n minus 5 minus 2n plus 7. Okay, so same thing, we're going to distribute a 1 and a negative 1. So here's the 1, here is the negative 1. We're going to distribute to everything in our parentheses. So that gives us 4n, then 1 times a negative 5, negative 5. Negative 1 times 2n gives us negative 2n. Negative 1 times a positive 7, they're different signs, so then we have negative 7. Oops. Combine like terms. So here's ours with an n, and here's our numbers on their own. Gives us 4n and a negative 2n gives me 2n plus negative 5 and a negative 7, negative 12. Right? That's number 2. So if you're still copying, remember you can pause or you can go backwards in the video, rewind. All right, I'm getting there. If I can go layer by layer, it's kind of nice. All right. Oh, undo, undo. Touched the wrong thing. All right, that's at least better, right? Okay. Number 3. So we've done 1, we've done 2. We are on number 3. Okay. Number 3 has negative 2n plus 4 minus 2n minus 4. We're going to distribute a 1 and a negative 1. So 1 times negative 2n is negative 2n. 1 times 4 is 4. Negative 1 times 2n is negative 2n. That's this one. And then we have negative 1 times a negative 4 gives us a positive 4. That's a plus. Okay. Combine like terms. 2n and negative 2n gives me negative 4n. Positive 4 and a positive 4 gives me 8. 4n plus 8. Done with 3. Oh no. I'm so bugged that I didn't delete that. Honestly, no big deal, huh? All right. Number 4. 6n minus 3 minus 4n. Do you get the feeling that this homework is really getting you to practice seeing that negative before the parentheses so you can distribute it? All right, so we're going to distribute a 1 to 6n plus 3. And the reason I write this in every time, it's just, kind of mentally, it helps me know what I'm doing. Okay, so I'm going to distribute. That gives me 6n and negative 3. A negative times a positive gives me a negative 4n. Negative times a positive gives me negative 5. Combine like terms. Here's with my n. Here's with just my numbers. 6n and a negative 4n is 2n. Negative 3 and a negative 5 gives me negative 8. Do you see how adding the negatives, it just makes it so easy for me to understand that this is going to be negative 8. So that's why we do that. 2n plus negative 8. Good? All right. Okay. That was 4. On to number 5. 5 is negative 3n plus 5 minus 3n minus 6. Okay. I don't think I did this earlier, but I'm going to add the opposite within the parenthesis. There. All right. So distribute a 1, distribute a negative 1. Negative 3n plus 5 plus negative 3n plus 6. So these two different signs, so they are negative. This one and this one, same signs, so it is positive. Okay. Combine like terms. Negative 6n plus 11. All right, hopefully you're getting these. There's just 2 more. Why don't you see if you can do them on your own if you're not already? Got too wild in my erasing. Okay, number 6. 5n minus 2 minus 2n, oops, I'm sorry, negative 2n plus 8. All right, we've got a negative in a different spot. We're going to distribute a 1 and a negative 1 here and here, here and here. So that gives me 5n. And of course, I'm going to add the opposite. Gives me plus negative 2. Negative 1 times negative 2n is positive. Negative times a positive is a negative. Combine like terms. 7n plus negative 10. All right, last one for this set. Okay. Number 7. Negative 3n plus 4 minus 5n minus 6. Add the opposite. 1 times negative 3n is negative 3n. 1 times 4 is 4. Negative 1 times positive 5n is negative 5n. Negative 1 times negative 6 is positive 6. Combine like terms. Negative 3n and negative 5n is negative 8n. Plus 4 plus 6 is 10. All right, you good? One more problem. Number 8, and this one, look, see, I did plan to give myself some room to work. Didn't work on the last one. That was fine. All right, so number 8 says, the entry fee to a fair is $4 and each ride costs 50 cents. If you spend $12.50, how many rides did you go on? Okay, slope intercept form. I love seeing this. So this is what the main thing that you'll be focusing on in 8th grade math. You've already seen it a couple times this year, and real life application, because everyone says we don't use that. Well, you do, you just don't realize what form you're using. So I get all nerded out on that one. All right, okay, so entry fee to a fair is $4. Okay, so $4. Let's see, how much room do I want for this? We'll move it over to this side here. Okay, so it's $4. Each ride costs 50 cents. So Okay, we don't know how much each ride costs, but we know that you spent $12.50. Okay, so you see how I wrote that out? This is the form that I'm using. So watch this. Y equals mx plus b. Okay, so B is your beginning amount. So it was $4 to get into the fair. Then each ride was 50 cents. Okay, that's your movement. So then we just don't know how many rides did you go on. Y, this is how much you spent in all. Okay, so now we need to see how much or how many rides we went on. We know how much they were. They were 50 cents each. And we're going to solve for X. Now on here, the reason that I put that each ride was 1/2 is, if you've heard me talking about this with slope, that's rise over run. Okay, rise over run. And that's for if we're going to graph it, which we're not. So I'm going to move that back to 0.5. And we'll have our decimals. Okay, and of course I have my calculator here. Okay, so to solve for X, we need to get X by itself. So first thing is we need to get the 4 to the other side, and we're going to do that by adding the opposite. So I'm going to add -4 plus -4. So that's going to give us 12 minus 4 is 8.50. Right, so I think it's $12.50. We already spent $4. We have $8.50 left, and that equals 0.5x. So we have 0.5 times x. To undo that, we have to do the opposite, which is division. So whatever we do to one side, we do to the other. So we need 8.5 divided by 0.5. 0.5 divided by 0.5 is 17 equals X. And that's number of rides. So 17 rides. Sounds like a pretty fun fair excursion. All right. So I will say for some of you, it's easy to not be doing your math work. You can just stare at your computer, maybe doodle and draw. But I want to remind you, whatever you do now just benefits you. Okay, so I will be checking your work when I return. You will have a test on this. Yeah, and I know you can do it. All right. Make sure that you're doing your daily notes. Remember, this week you're actually copying 7 notes total. On Friday, you'll only have a couple for classwork, and you'll have the rest of the time to work on notes. Okay, so I hope that you're making it a great day, and that all you do, remember who you are, remember what you stand for, and lead by example. Miss you guys. Bye-bye.